Good evening. Welcome. It's a great pleasure to welcome Marc Mimran to the AA. Marc is a professor of architectural construction at the Ecole d'Architecture at La Défense and is one of the leading engineer architects, I think, practicing in Europe today. Marc has a very interesting background because he has studied not only engineering, but also architecture and mathematics. And it is this, in a sense, liminal condition between a variety of different disciplines which has had a major impact on his practice and his teaching. Somehow, most of his work is at the interface of structure, questions of structure and construction, project and theory, engineering and architecture. His teaching is obviously based on the belief that you cannot make a project without a vision of construction. One of the things that I think is very interesting about the organization of the office, which works both as an engineering office and an architecture office, is that a lot of the projects are done in the office for other architects, and then they also have their own architectural work in the office. And this, I think, is a very interesting combination, to be working with others and then working on your own projects. Currently, the office is working on a number of projects, including a bridge in Paris, which happens to be the last bridge on the Seine that the office won in a competition a couple of years ago, a series of high voltage towers, and the recently completed Tollgate at Melun, which is a gigantic 210-meter 45-gate tollgate, for which the office and Marc won an award, one of the two given this year by Le Moniteur. Would you please join me in welcoming Marc Mimran? Thank you.
Thank you for coming. As my English is not so good, I took a lot of slides, so you'll see that. As I'm working as engineer and architect, I choose tonight I hear my heart. It's normal? It's like boom, boom, no? No, sorry, no, it's... Shall I move it? Can I move it? No, it's kind of, yeah, it's
quite nice.
No, it's like, don't. No, my heart is on that side.
It's okay. No, that'll be fine. We both can go.
I'll show you some of the projects we're working on now. But I wanted to say that, first of all, it's kind of strange thing that we're going to speak theoretically about the way of making things, which is usually we speak in an architectural school, we speak about theory, on theory, with theory. But in that sense, my theory is the way of making. And for you, it's kind of theoretical because you're not working on it. You're not in the world of making. And I hope you're going to go in that world. So I want to show you really how the project we are dealing with are always thought as project. In the process of projecting, we are thinking about the way we're making things, about the machines that will do the project. And in that way, we are in a very special situation. As an engineer, we have steps on which we can stand, such as statics or gravity, for example. which are much more simple than for every architect. So I want to speak about simple things. One of the things is that we work with laws of material. And so you will see here most of the projects I'll show you tonight are in steel, but I want just to say that we are not working on material as if it was in the fashion, as if a material was better than another one. Every material is equal. Every material can be modern. There is no way of being more modern than with a material than another one. So the rationality we are working with is linked more with the way we work with those materials. The second thing is statics, like I told you, and then we have a few ways of working with statics, which is a way of not thinking, because we can do things like hinges, embedment, encastrement, bending, shearing, all those things that you are working with. We work with them, so it's much simpler for us. And then that's why I want to show you simple things. And the work with gravity is not only the way of taking forces and taking them down. Sometimes engineers are taking the forces up, not only down. Sometimes architects are taking the weights down, not only up. So the idea of working with gravity was, with this idea of working with gravity, we work a lot with light. So what I wanted to show you tonight is more the relationship between light and gravity. So as I told you, my English is not so good, so we'll see pictures. And then I think after that it's going to be easier. Okay. No, I have to work. As I told you, the idea of working with materials is something very important, not only in the point of view of making, but in the theoretical point of view of making the project. So material is not only a way of making a project, it's a way of thinking the project. And if you look at those pictures from the 19th century, 18th century, you see the way of the first idea of molding. This idea of molding was an idea that will become the basis of concrete. So you see, it was molding earth on that time. And you can see that from that picture, you can see that they are taking care about water. So they have good stones with the water on the floor because of the water. They have concrete molded. And so from there, you can imagine that you will see the way that we will fix the thing together. And they are working with instruments. Every time they show the way of making, and it's in the architecture. Oh, what did I do? Yeah. The other way is the statics that I told you, and a very simple way is to work with this triangular form, which is a way of making things getting easier. But in this drawing, and I show you those drawings because sometimes as we are going in the virtual world, I mean the virtual world of representation, we forget that we are not only with images, but images of things being done. And even in the project, this image is not telling you what is going to be the project. It's telling you how you're going to build it. If you can see here, you see those people that work on the site, how they will use very good stones in front and bad stone inside the barrage. And they speak with the geography. They work with the earth. So in any case, when you speak about a drawing, you don't speak about the image, but the image of making. And for example, you see this animal is in a form somehow in relationship with static. one of the most important idea is to make the void, not to give more weight or less weight, but to see where you put the material and where the void can come in the structure. And coming from these triangular forms to the icosaedron, the Graham Bell tried to make stiff structure, but with lightweight structure, but with the idea of introducing the void inside the structure. And this idea of making the void and not to know how to put things together is maybe the most important thing in which we work. The other thing is, I told you, is that with structures, we are in an easy world because we think that if we have an inch, it can go, stiffer, and it can go in a slower way. If we have an inch, we can show it. If we have an inch, sometimes it's not an inch, because if you look at that, it's for the Eiffel Tower. It's supposed to be an inch structure in the calculation, but in reality, because of the problem of scale, it's changed really the structure we're dealing with. Sometimes we take our ideas of structure from nature, and I'm not giving you that as an example for what we are supposed to do, but just the way we are supposed to think about that. Like Viollet-le-Duc was thinking about the hinge, he was just thinking about the branch of a tree, the way it can be hinged or fixed point. And if you look at that, you see that the cantilever is getting deeper here. Here it's fixed, but here it's hinged here and here. But what is really interesting is that the connection between those two surfaces, which are quite complex, are done in a way of taking out material. So if we look at things about like where the forces are going to, how they are passing through, we can think about the idea of continuity and discontinuity, and which is really the main idea of. I don't tell you that the best thing is to go from continuity to discontinuity or the contrary. I think the most important thing is to know how to pass from one side to the other one. And if you look at this, for example, you can see that here, because of the wind coming here, you have more material and less. And this irregularity is coming from getting from the point of continuity and introducing a hierarchy. And the other way of introducing this hierarchy is to introduce main members and discontinuity in the space. So we are coming back to this idea of the vacuum, this idea of the void inside the material. I wanted to show you those pictures before I show you my work, but I wanted you to now, coming from that to the project is just telling you that we are not just working with material, but the way of thinking, the way we can use it. This is a footbridge in Toulouse, in the south of France. We were in the situation, the special situation, where we've been working on that project actually with Alexandre Chemetov. And you see, when you begin with a project, the most important thing I think is the geography, the point you are. In that situation, we are on a highway, but we look at the highway as it was really flat. But in reality, we had a small slope here, 3.5%, which is almost nothing, but not nothing. So here we couldn't put another we could put here a foot, but not on the other side. So I could imagine another bridge without 2 feet. But I decided that, so if I can put one here, why should I? Why not? And from that situation, we introduced the idea of giving an orientation between the landscape, between the countryside and the town in the landscape. And from that simple idea, we began with repartition of forces and moments. So here it's fixed because of those 2 elements, and here is hinged. And this is a very, very simple idea. And from that simple idea, you begin with the idea of form. That's the first time I speak about form tonight. And I'm not trying to speak too much about form. But the idea of form is not coming from itself, but it was coming from those ideas. And in a way, the form of the structure was not very nice. It was like, it looked like a sausage like that. It's being deeper here and less there. And I was working with that, and I was saying, why is that beautiful or not beautiful? Or usually you are with those questions. And I try to avoid that question. And to work only with the idea of making it. So in that situation, we had to fold a steel plate in an elliptical section. And if you fold this, and if the elliptical section is constant along the bridge, it has to be constant, because if it's not constant, you change the mold every time, so it's very complicated. So we begin with that. And then it gives the form, and then so you can see from here, because it's deeper here, it's larger here. And because it's fixed here, we have 2, and because of the street which is doing that here, and that here, so we have two elements. And coming from that, we went to the fabrication. Very, very simple way of fabricating. I show you that because you cannot think about the form without thinking about that machine, which is a very simple machine. This guy, he looks at that, and he pushed that tube in between the 2 others. If he push it strongly, it breaks everything. If he pushes not enough, it doesn't do anything. So it's everything, all the form of the project is coming from the thumb of that guy. So you have to think about that, because if not, you're working in an idealistic world. And sometimes it works, sometimes not. So if it doesn't work, you... And we work on that, with... it's like a way of making a trouser or everything. It's a way. It's like la couture, pattern making. Yeah, but we had to make very simple one, so that the guy could make it. And so it took a long time, and then some day, la baleine, we call that a baleine, the whale, was on the site, and we began to move it. That's very important idea, is the fact that you can put a bridge in one day on the position. So we build it in the way that we could build it in one day, so that we couldn't cut the circulation here. And then, so you see that from that first issue came the form of the whale, and it was double curvature, of a curvature that way and that way. The water is coming here, so it gives you lectures of the structures, lectures of the form through the fabrication. And I love this idea that working with that guy, his thumb, his eye, and working together through the idea of making it, and not only thinking it, we could put that form in the right position. You see, there is something very important here. We had to put, if you see the bridge here, it was put on the upper position here, it's here somewhere. We put it 1 inch on top of the final position, so that we put it that way. No, let's do that the other way so you understand. We put it that way on 1 inch on top of his last position. So it's like that, and here it's fixed. So we fixed it here, and then we take it down so that it pre-stress the steel here. So that here it's in tension and here in compression. If you don't do that, the form will not respect what the structure is supposed to be. So the fact that we thought about the way of making it in the site was very important, you see, so that we can pour it, the concrete, and then we put the bridge here, and it's fixed at the end here, on top of that, and then we take it down so. So it gives you, it's a lot of problem. But something very good with lectures, so you speak about things like if it was very simple. It took about 2 years and a lot of trouble. But it's, it's not bad. We took that we, oh, I should do, no, oh. You see here we put light in the rail here, and here this is a very bad material. It's plexiglass, which is supposed to be not very good. But if you think about that, if you speak with those people, they can do they can do it in very the white as white as you want, so that you can reflect the light. So it's not such a stupid material, because you can make it 60% transparency and 40% translucent. So during the night, I have no picture about that during the night, but during the night you have the light is coming from there, and it's going through that, so you have an homogeneous light. But see, coming back to the geometry of the structure, it's coming from the way we thought it. And after a while, which was like, it's in a strange position because you have other regular bridges. But I love the baby. And you see here, on that bridge, here the water is coming. Okay? So the water is coming from outside the bridge, along the side of the bridge. So from that project, I imagine that we could do for another project. This is a competition for Berlin. It's on the Reichstag, in front of the Reichstag, on the Spree. And we took the idea of the water, but instead of the water, we put the people on top of that. So that here it's a walkway, and here it's for the cars. So that we could imagine a connection between this point to that point and to that point. So you can walk along the structure, on the side of the structure. You see? So from the structure, and outside the structure, we took in cantilever this footbridge, and here it was for the cars. And this is interesting, that working from one project to the other, and I told you that the most important thing was the geography. The geography of that side was quite different from the other one, but here, looking at the different situation of getting from the water to a midpoint, to the upper point. So we had 3 positions for the people walking, and I thought that the structure should speak about that. The structure is not only for itself, it's not only a movement of forces, it's mostly a movement of people. And so we work on that idea and we had only the second prize. So after that, working on that project for Paris, which is, on that one we had the first prize. This is in between, if you know Paris, the famous pyramid, le Louvre, Pyramide du Louvre, les Tuileries. And here you have a lot of museums. You have le Louvre, le Jeu de Paume, l'Orangerie, which is going to be rebuilt. Here you have Musée d'Orsay. So we are really in the middle of the town and in the middle of the museum connection in the town. And the project is to link on the Rue de Solferino, to link the garden to that the Rive Gauche, left river to the right. And the idea was to connect that. Here you see that's Museum d'Orsay. That's another one, Musée de la Légion d'honneur. And so it's to link those two parts. But the situation is very particular. Here you have a lot of cars on the right side. On the upper side, on the upper side of the right side, you have a lot of cars. So you cannot walk really here. You cannot cross here. And on the other side, which is exactly the contrary here, downstairs, you have a lot of cars here. Along the river, cars are coming here. So you cannot cross here. But it's very important to have the connection with the river for the pedestrian, but they cannot cross here. So if the people want to go from here to here, they will not do that. They won't be able to do that. Ah, yes. So we had that bridge, footbridge. That was a situation when I arrived. That's a temporary bridge. It lasts 32 years. So we decided to change it to that one. That was the picture of the competition, the first drawing. The idea was to come in the structure and to go along the arch, to have those two movements of people inside the void of the structure. As you can see, the people will come from down here and go on top of the bridge through the upper position. That will be the most common way of walking. So the idea of structure is really linked to the idea of the movement of people. It's obviously they will be able to go down here or to go along here. So they have a cross situation on this spot. And so we thought that a structure had to speak about that. So it's supposed to be two bridges, and those two bridges are unstable. You see, they are hinged here and here. In this direction, they are fixed, but in this direction, they are hinged. And their stability is coming from one to the other. So it's the void inside that make it fixed. One is, if you look at one bridge, it will fall down. If you look at the other one, it's the same. But if the void in between them, fix them. And it's in that void that the people will walk. And then another thing which is very important is that the footbridge is not a bridge. It's not a bridge for cars. That's not the same light, the same the same weight to carry. But as a contradiction, here we have it's 106 meters from here to here, which is 34 feet? No. Huh? 340 feet. So it's quite long. So we had to make it, you had to give the feeling that it's light. So we work on the idea of transparency. How to make the void inside so that the people will walk in. How to make the void outside in the arch without any braces. So that, braces is more a vocabulary of the 19th century. So we were supposed to work with bending along the arches. We have truss forces, but we have bending too. And then inside the material, we put that void. So it's here, the form of the structure is higher here and deeper here than here, so that we can have more void on that point, which is supposed to be the fixed point, which is in relationship with that one. So you have to understand that the way of making the project is coming through the idea of circulation of people, circulation of forces, and the way of building it. We were thinking about molding those pieces. So now we are molding less than we were thinking at the very beginning because of fabrication problems. But the people will stand inside the structure, so they will be directly in contact with all the elements. So the scales of the element are very important in the way you will look at it. You are not in a situation where you look at it from outside. You are in it, which is quite different and not very common. So we had to design all the pieces so that the people in their contact with the structure will feel it. And we still have to think that it's not a chair or it's not a table, it's a bridge, so you don't draw it the same way. You don't make it like. So you have to feel the movement of the people and the movement of the forces. You have to feel the way they will come. It's like a window in the sky. You see, they will walk along that and discover along the promenade the water, and then from top of that they will be on balcony on top of the river. You see, from the very, we had that pole, we took it out. But that void, because it's asymmetrical too in that situation. I wanted it to be symmetrical with the river, obviously. But the site is different from one side to the other. So I used the void here. Usually in the bridges where you have a lot of forces, you push that on, you have a lot of stones here usually. So now in our situation that the forces are getting here, I took it out. And then you see the people will do that. They will come down through that, go up on top, look at the window. I mean, arrive to the place in the middle. So you have to understand that this project is really linked. It's a link between structure and a promenade and the way the people will be in it. So it's not only a problem of construction here. And the construction has to be part of that too. So we are waiting to build it now. We are waiting for. Waiting for. If you have money, tell me. But we destroyed the old one anyway. You see, that picture it's about 12,000 hours of work later than the first one. So it's almost the same. I'm quite happy about that. We work a lot. We didn't do anything. We work a lot. I can tell you. But sometimes you work a lot and it doesn't appear, which is quite good. It's not very good when it's not like, it's like when you invite somebody, when he eats, he doesn't have to know how much you pay for that, So when you work a lot on a project, you don't have to tell to everybody how many hours you spend on it. And it's a problem of style somewhat. No, we'll talk about that later. But so here it's a tower, it's a light tower. I show you that because it's a very simple model. It's a strange situation. We had It's a strange story too. We do have time? Yeah. It's a strange story because we had to, no, it's on a bridge. It's not a bridge, it's like a bridge on a place. And they had 45 small lights on top of that. So I said, why we shouldn't take all those 45 together and do 2 lights. So it was 2 lights like that. With the same amount of money, we said, okay, we took the money and put one on top of the other. And then I began to draw the thing, and then I understood that we could take the 2 lights and put one on top of the other. So so it can become bigger. So this is 49 meters high, which is 150 feet. It's exactly like the angel of the Bastille here. So, and then we began to draw and make the project, and then it's symmetrical light tower. And then after, quite at the end, I understood that half of the lights were not useful. So the project was symmetrical, and they had false lights on one side. So I decided, okay, we change everything, and then we make another project. A project which was not symmetrical because the light was only useful on one side. It's a fact that I didn't know at the very beginning. And another thing is that you need an elevator when you go on that, on 150 feet you need an elevator. But the lights here, you change them every 2 years. But the elevator, you need to maintain it twice a year, which was quite strange. You need an elevator to go on top, and then you have to maintain the elevator. So I said, no, we take out the elevator, and it began with the staircase. And then one day, it was quite similar from the model. One day, it comes to the site, and so you can understand that sometimes you have problem of scales. You don't work. And the idea was that in one direction, this flange is continuous. It's getting from continuity to discontinuity on top. So we have here, it's quite full, and there it's getting empty and empty. And on the other direction, it's only discontinuous members, which take the tower together because of the problem of torsions. And we did a lot of calculation for that, because it's quite slender like that. And something very interesting was that when we did the first calculation, we know that something very bad with structures working with wind is when they have a dynamical answer around 1 second. So we did all the calculation, and we knew that we had to be out of 1 second. And my drawing was perfect. It was exactly 1 second. So that we had to change everything once more. So I just want to tell you, it's Fraissinet was an French engineer, the guy who invented the pre-stressed concrete. He said, he did drawings like that, and then people were working on calculation, and then they came back to him and said, it doesn't work. So he had 2 answers, but 2 possibilities. You change the drawing or change the calculation. Usually he said, change the calculation. And it's like that now. So the idea of gravity and the idea of movement, with the idea of light were on that project at the very beginning. And the idea of transparency from one. So it's a very simple idea of parabolic curve because it's fixed here. And you take this very simple idea and you work on that. But you have to work. And now we working on that project, which is a high voltage tower. You have a lot of them here, everywhere in the world, because when you have 400,000 volts, you cannot put the lines underground. Nobody knows to do that in the world. So they put that competition to make it, you know, I don't know why they did that, but we answered, so we won it. With Jan Ritchie won. We were two first prizes. And so Jan Ritchie is doing a very different project, a very small one. It's like an F. It's exactly the contrary. It's small and large, and we are doing high and slender. So that's why I think they didn't know how to choose, so they choose first prize. So the idea is to work with the horizon, so that you see, something very important is that you can read that line every time. If you are in front of it with the light in one way or the other way. So one thing was to work with the horizon. The other thing is that we have eight type of pylons, which are supposedly completely different. So what we did is we used that as, you know, it's like things that when you were kids, you used this kind of thing that you put them together, you know. So what the idea is to use the elliptical section in one way, and then if we need it, we can return it and use it with 2 poles. And if we need it, we can return it and use 4 poles. And if it's a higher one, we cut it somewhere. If it's a smaller one, we cut it. So we use only one mold, because I was thinking about doing that with mold iron. Now we are doing that only those pieces with mold iron, but it's still the same, so we can cut it along the landscape. And so it will work with that. So the light will come in the transparency of the part which is supposed to be the stiffer one. Sometimes it's very important to give the lecture of lightness and resistance, you know. So here, what I want is that you can capture the light inside this form, give the transparency along the horizon, and let the cows tranquille, quiet. So that, you know, with this only model, we could develop all those 8 type of pylons, so that along one line you won't have one type and then change to another one and then to another one, so that you can have a continuity in the landscape, even if the landscape is changing. We need a model for that, so that, and that's quite high. That's 220 feet, and very slender. Like, you know, it's like a roseau. Yeah. But the fact that you can see the sky here is very important, so that you have not the same relationship with gravity, you know. And now I want to show you some of the recent project we did with covers. Like this is a project which I show you because nobody is really interested, and overall on architectural schools, of the way people are working on the site. And I don't understand that. You know, we have thousands of books on the relationship between Deleuze and architecture. No book on relationship between workers and architecture. It's quite strange, isn't it? Who is working with his diploma on the, comment ça s'appelle, un marteau-piqueur? Hammer like that? Did you have one diploma on that? I'm not sure. And you see, and I say that because I'm on the same situation as you are. You know, on the 19th century, now it's not really different. You know. So we have to think about that, because the site, as I told you by the very beginning, the site is in the project. So if you think about the site in the project, you have to think about the way that it will be built in the project. It's a very small, it's large like that. It's a very small cover for. But the idea was working with a compass like that, you know, it's open here. So it was more the idea of working with an industry and workshop. So we use plates of steel and we cut them. So if you use a rectangular plate, you cut it in the diagonal, you can return it. So you can do that, and with the other plate you do the other one. And then you open it, and then you fixed it here and hinged it here because it's like that. And so you can play like that. And then when it's fixed here, and here in one way, in one direction it's very resistant, and the other one is not. So it's a way of cutting metal. So you see, it's large pieces, which are all different, coming on one point, which is very fragile. So we work on. That's a way of, you know, working with the importance of connection. And then another thing I was telling you, that we were working in the relationship between industry and workshop. Because if you buy that kind of cover, if you buy it already done, already made, first you cannot find it because it's not the good radius. Second, they will never sell you that because it's only, you know, very few pieces. So we decide to make it, to reconstruct it with a very low cost elements. And this insulation will give the resistance of the skin. In that case, that skin is stainless steel, and we had the right to make it because, you know, it's in an historical center of an old town, and I said to the architect that he will have the reflection of his church, so he was happy with that. And coming back to that, you see, you can draw whatever you want, but you have to think about the way it's going to be built and where the guy is going to put his finger. And that's an easy canopy for how to fix it here. So you fixed it here. So if you decide to fix it here, you have more material here than here. And the idea here was with the water. So here I wanted to have a straight line, but here it's not straight, so that the water will go through, will fall down here. So it's folded plate. So if you want to have a folded plate here and a straight line here, and you have a double curvature. So you have to make a way of, try to find a way of making it. And in that case, we use those members. And here it was hinged, and here it was fixed because of the fact that it was more stable that way. So we used, for example, in that case, you see this is larger here than here. So we use a tube, and we cut along the tube in the diagonal, and then we return it so that it was larger here than here. So you can work with those industrial products, but transforming them. And this is a cover for a stadium. So here you have 2,000 people here. The idea was to put you see, usually the athlete, they don't use it very much, and they go to that vestiaire where they change out there. Changing room. So, and you don't know if they will use one or two or three. So we put all the common rooms to get underneath here, and the changing rooms outside. And we work with this idea. If you see that, it was an architectural project from an architect, myself. a continuous frame like that, beam. And then what was the huge change from that project when we built it is that you see here, it has a little bit of, it has, you know, it's changing now. Here it was continuous. Here we change it like, you know, we curve like that because of the moments here and the fact that it was fixed here. So you see, I'm very proud of that curve because I didn't find it myself at the very beginning. So we won the competition without the curve, but so we have the curve now. And you know, it's very simple. It's just the way you cut because you can do those things with anybody. Everybody has, you know, a machine now with the computer. You take a steel plate and then you cut it the way you want. So we are now trying to find out the vocabulary of soldering and the vocabulary of cutting the steel plate. This is exactly the same situation as during the 19th century when the people were trying to pass from rivets to bolts and now from bolts to soldering. And so architecture is, you know, it's a strange thing to speak about those simple things. Welding. How do you weld? Very well. And that's your project. Which is quite interesting because, you know, if you want to weld it very well, you have to put that so that the welding will be inside of that. And not at the corner, because if it's at the corner, it's quite, they cannot make it very well. So it's harder to make it that way, but you see the light? The light comes here, so it gives you a straight arête, which is quite important. And you see, we invented a machine, a special machine for that. I don't show you tonight because I thought that we had too many slides, but we invented a machine that can push the steel plate and give it more stiffness and take the light. Yes. And so in that case, you are inside that structure, and here you can see through it those changing rooms. And that plates was, we did draw it at the very beginning. We had two, and I changed it for one, which was much better. I mean, I think. And so that the water come all over from the cover, it comes here through that one, go inside of that, and then you put it, you have these white stones, and okay. And then here, you see the concrete. There is something I hate very much is usually, I mean in France, in England you don't do that very much, but in France usually we build it in concrete, and as it's in the fashion, we put steel on top of that, you know, to cover, so it's more high tech now. So I decide not to be, you know, if we have to build it in concrete, so I show the concrete, and then we had a very special system of insulation so that the insulation came here, in beneath that, and this is the resistance of that, the stiffness of that plate is coming from the insulation. I don't know why I talk about all that, but anyway. And I want to finish with that project, which is, you have 5 more minutes? That's a strange situation because it's a toll gate. So when it's a new highway coming to Paris, and they imagine that it will be, I don't know what they imagine. So they decide to make it very big. They imagine that they will have a lot of cars. I can tell that here because you will never say that in France. I don't know why. So as they asked me to make a very big one, not to, because it was a competition, we had to make 45 tolls like that. 30, 29 that way. And so they decided, and it was a strange conversation with the guy. He said, when you come in, you have to do that and that. And I was thinking about when you come in Paris. And no. When they were talking about that, they were talking about their highway. So when they were talking about coming in, it was in the highway. And naturally, I was thinking that Paris was more important than the highway, but for them, it was not that. So we were speaking together before the competition, and it was a misunderstanding. So I understood that it was not symmetrical for him and for me. The way to come in Paris was not the same thing for me than for him. So we decided that, and it was not symmetrical. It's not a toll where you can change. You cannot go that way, and if you have more cars, you go the other way. It's only 29s that way, and 16 coming in. So you have less coming in because you just take your ticket, and you have more on that when you go out. And so I was thinking about that, and there were two things were very important. One thing is that usually when you do toll like that, you do large span, but it's not useful. You can put your foot every 3 meters. So I was thinking, why everybody is doing very huge thing? And it was a contradiction because you have to make a very huge thing, because if you don't do that, first the guy is not, because he pays, so he wants something very important. But which is, I think, more important that the people when they arrive, they don't feel it like it's very important. So we had two scales. One was local one, and the other one was larger one. So I was thinking about that, and the idea was to use a palm. The guy is in his room like that. He's like a nabab. Just take the money. So we say, okay, we could put just a palm on top of his head, and then from that, everything began. And so you have the palm. So you don't want the palm. If you do that with the palm, it's very easy. So you don't want the palm to have a foot here. So you have to take it on top of that. And if you go here and you want the arch. I wanted this direction because of the larger scale. So we had to divide the forces coming, because the forces, they don't like to take a long direction if they can take a smaller one. So a natural one, a regular force, will come here, and if it can change, if it can go that way, which is about 100 feet. No. 1,000 feet? 30 meters? Yeah. So it's a long way. If it can take a long way or a shorter one, it takes a shorter one. So this becomes to be stiffer than that. So we said, okay, if it's stiffer, make it stiffer. And if you make it stiffer, the force comes. So, and that is not useful anymore. So we had to, you have to balance it every time you speak about those forces. And we work, you'll see that this model, we work on this idea of the water coming here and the light coming through that. And so you'll see that. So the idea was to take, I don't know if you see something here. So the water will come here and go here along that to that point. And we put, it was a strange idea. It was just before the competition. I said, okay, why don't we put these small globs like that so that the light will come along here. And then we counted it. We had 14,000 of those. So sometimes you decide something and then, but it was very important for the project because, coming back to that. If you see that section here, it's curved here, which is something very strange. Usually, it's curved that way, okay? It's curved that way, okay? But now it's curved that way, here. So the section is not a rectangular section. It's like that. It's not just only to make problems. We had a lot of problems doing that. But so that the light coming along the palm will go, very smoothly. And then you will have a very strong shadow here. And if you do it that way, you see all the welding. If you do it that way, it gives you resistance to the section. give resistance to the section. It's stiffer. So I decided to make it. So we had to invent a machine for that. You see? That is like an olive, and this is an hyperboloid. So the steel plate comes in and it curves that way. It's a very smooth curve. That's very important. And then they solve it, they weld it. And then after a while, you see, here it's curved. So that line with the welding will go along that line. The water will go along here. You see that? You see here, it's curved that way and then that way. So from that we can have that continuity. It's curved that way and that way. So that here it's stiffer. So we have more inertia here. And we have continuity of the form coming from that, very thin, larger, and thinner. So that when you see it's very thin. But here you have more inertia. I don't know if you're interested in that, but. And then we invented a molded piece, because here you have to connect all those directions. For this bracken is curved that way, so that the light will go along it. Here it's suspended, and here it's like I told you, like that. So it's coming, the forces are coming here. And so now we have those two directions, and then we had to invent a special molded piece to connect those directions. So it's a problem of geometry, very basically simple, but by the end it's becoming more complex. And I had a lot of pleasure working with the molding steel. So we had to choose the sand, so that the granulometry, this be more. So we did the model. So that you see that piece, it's coming there. It's curved. It's not bad. See, you take that, and the water coming through it and goes here. The water comes here, goes through that piece, and it has a lot of connection. Here, this is 8 centimeters thick, which is 25 inches. Possible? Yeah. 2.5. No. I have a problem with those inches. And working with this idea, you see, you work with an element which is continuous, but it makes discontinuity in between the other. And from this discontinuity of the element and this discontinuity of the elements, you begin to construct a space which is himself, it looks like more continuous, which is quite interesting. You work with elements, putting them together, disconnecting them, and so because of the problem of the light, the one I told you before, so this is straight and this is folded here, and this is straight here, so you have a double curvature. So we use these polycarbonate elements. It's molded like, it's like the nose of the TGV. It's just the same technology. It's like a boat, but as we had a lot of elements, we could make it. And so the light is coming through that, and the water. And we work with complex structure, but complex geometry, but it gives you this idea of the volt. You can feel it. This thing, we work hours and hours on that idea of curving the steel along the beam. But nobody sees that, but I'm very happy about that. I feel it gives sense. Our work is about that. Anyway, I can't finish on that, but really the most important idea is that you cannot work on form just for the pleasure of it, even if you have pleasure on that. The most important thing will be to give sense to the material in the space. And to give sense is to work with those ideas I told you tonight about not only make give more complexity to things that don't need complexity. You need complexity to give, more reasons to the way you're working on, so that the people will understand that. And even if they don't understand that, I'm sure they will feel it, So, working with those ideas of giving more stiffness, less resistance, light and gravity form in the space, surfaces, virtual one and real one. I'm sure we give more sense to our work. That's what I'm trying to do. Thank you. Oh, yes. I was too long, maybe, no? Yeah.
So Marc will take some questions.
But if you're not too tired.
Any questions?
The first one is
Well, I will ask the
the
first
other one.
I'm always asking questions. I was, in the introduction, I was talking about the fact that many of the projects in the office are also projects that you're working with other architects, where you're acting as the engineer. And I think that obviously it's been fantastic to see the work that is coming from the office, which is what the office itself is producing. But I think in the context of the way that you were constructing the conversation, it would be interesting to get something of your reaction to the differences in a way that you notice sometimes between the kind of work that you're doing yourself as an architect and engineer, and in a sense something of maybe the inconsistencies that you would notice in the work that's brought to the office by other architects that you work on. I don't know if that makes sense. For me it's interesting because, for example, in the context of the UK, and you were discussing earlier the work that Peter Rice, for example, has done, there's a very special relationship between the engineer and the architect, to the point where a lot of the engineering ideas in a way become very important architectural ideas in terms of the conceptualization of the architectural project. I wonder whether you have something that you notice in this way that you have to work on your own projects and then you have to work on somebody else's project. What does that do? What kind of issues does that raise
There is
in the work?
There is something very important, is that I'm not in that position that I need to impose my way of thinking on the architecture of other people, as I'm doing my own. I'm not, my schizophrenia is not like so large so that I can say, okay, that day I work on my work and that day I work on the other one. But I don't need to impose this kind of issues, this kind of reflection on those projects. If you look at the project I'm working on, for example, I worked on the new French Ministry of Finance. You see that building from Chemetov? It has nothing to do with that. But I was happy to work with him. And I'm happy by the fact that they think what they are doing, they know what they are doing, and then we try to make it together. And I don't need to say, okay, that's why in a way my work is quite different from the one Peter Rice did. Because when he was working, you could feel that Peter was there. All the project he was doing with Rogers or Foster. I don't say that Foster didn't do anything, or Rogers, but I say that Peter was working with them, and you felt it. You felt it. I'm working more on their way, on the way they are doing their project, not on because I'm doing my own project. That's another world, and they know that. Sometimes they don't like it, and because it's more expressive. Usually, I'm working with architects that are less expressive, like Yves Lyon, for example, or so. And they don't want me to be on top of them, but we are working on the idea of the project, and not on the way it will it will become a style of, So it's quite independent, but I was really happy. I say I was because I'm less working on that way now. I was really happy to work with them. I learned a lot. Just, people very different. Some of them, Christian Porzampar, he's more an artist. Siriani, I work with Siriani, Siriani? He's only Corbusier, everything was 26 centimeters, 63, 2 meters, 0.6, 2 points. So I said, no, the beam will be, 195. I said, no, okay, 2.6. Okay. No, okay. And it was always like that. So it's his way, and I respect it, But, my beams are complicated. But I was really happy about that. I learned a lot because they really feel what they're doing. So what we try to give is sense to their project through the construction. The construction is not only a cladding, it's not only a way of making things stand up. There is a very famous book of how to make things stand up. It's very important, but it's not enough. I'm sorry.
As a structural engineer, I'm a structural engineer as well, and I find that there's sort of a problem with being a structural engineer that doesn't apply to being an architect and doesn't apply to being a civil engineer. And the civil engineer is acting very much like an architect, directly for a client normally. And so the control, or the lead control, if you like, is very clearly defined. Now, I can see in your last project there was a real openness. You were acting as lead consultant, I presume, in that situation.
Oh no, I was alone, so I was leading myself.
The question I was going to ask was, I don't know, you qualify both as an architect and an engineer, I assume.
Yes.
I was wondering about the situation where, clearly structure is a dominant theme in that particular
Yeah.
program. Whether you would think there's a situation arising where you felt earlier that there's perhaps a problem with architects and architecture just now because they don't actually deal with construction. I like that photograph that they're now focusing on beam because the other issues seem more important or more important at this point in one's life as a student. But when you get out there in the real world, you're really dealing with that as your language. Do you think there's a situation arising where the engineer, the structural engineer, or the environmental engineer are going to become so important that they'll be lead consultants on projects which were previously led by an architect?
I really don't care too much about that because as I am both architect and engineer, not my problem, but it's
It's not your problem.
but no, it's not what I want to say. Is that sometimes, for example, you've been here with Alexandre Chemetov. When we're working with Alexandre, sometimes, he's doing the engineer, and I'm doing the landscape. I don't know anything about any plant, but, I try to say, and he say, okay, oh yeah, very good. So, and sometimes, he asks me questions, but, so I feel like if you have a way of transmitting this idea of the project, what carries the project, you can be either an architect or an engineer or whatever. That will give sense. If somebody is there to give sense to the project, he can be whoever he wants. So I don't really care who he is, if he's an engineer or not. The other thing is that, coming back to the guy with those bolts, I'm very afraid about the fact that construction is people think about construction as something coming after everything, something. You have the project, you feel it, you smell it, and then you now, how, and then, coming from the paper to the building, it's a very huge problem for the students. And I feel like if you come with this idea in the very beginning. If you know, because for them, theory and construction is the same thing. Because construction is theoretical for them, for you, for you. So why would you be more capable of understanding theory about theory than theory about construction? So I feel like construction can be a theoretical field, but a real one, not only a way of making things, a way of thinking about things. So if we every one of us think about that way, that way, it will come in the school. It will come. Everybody will feel that way, and you don't need to be an engineer to do that. Maybe, but you don't need to do that. That's the very important point. I'm very happy about that work, but I don't feel like everybody will need to do that because it's very expressive. So I feel like there's a lot of buildings that are not so expressive, which are as good as those ones. I mean, that's my way of making it. I don't show you that just to tell you should do that way. I mean, I'm very proud that I'm doing that alone, because if we were thousands of, doing things like that. So it's not a model for the form, it's a model for the way of, it's not a model, it's a way of thinking. So I think that it can, it can come, everybody can do the same, have the same way of thinking, but not doing the same thing. Is it clear? I'm clear? Do you understand? Yes.
A bit difficult, my question. Don't quite know myself. But what I find interesting about the work is that you're dealing with space. You deal with, I was quite impressed about your concern about topography, shape of the land, trying with your structure to show the shape of the land and the space of the land.
Yes.
And the space of an urban topography arriving at different levels of the city, making space, human scale space for people in the void, speaking about the void of the structure and not so much about the shape of the structure. And I find this very interesting, all these scales of space. Scale of land, scale of city, scale of human scale. I find this very interesting. But then you are becoming extremely expressive. And I think then it becomes, because of the strong expression, attention goes away from the idea of space and goes to idea of object. Do you feel like this? Do you feel a dilemma there as well? I feel a dilemma there.
The first part, I feel it quite well. The second one, no, I feel I really want, even if I'm not, I really want to be out of the world of objects. And somehow out of the world of art. I'm working with the shape, I'm working with the form. And those things, because of the way I'm making them, they are like perfect objects. And I hate this idea. That's why I prefer to show you how we make it, how is the solding, how is the light, how is, not to be outside of it. The problem of the object is that you are outside, you're looking at it, and you say, okay, that's not nice, but no. And I'm not in that situation. I really don't want to be in that situation, because I think that objects, are a way of pushing, objects in the city. They are the way of pushing apart the city. It's like a way of destroying the continuity of the city. But what I'm trying to make is just more continuity, more, sometimes I'm very happy about the fact that for Solferino, for example, for the Tal Bridge, is that it can be done. You know, we couldn't have done that bridge even 20 years ago because we use really recent technology. But nobody will know that. You know, I'm not saying that it's very high, new carbon, I don't know what, plex, you know, those virtual, you know, ism. I think that that project could not have been done 20 years ago, but everybody can think that it could have been here for 20 years. The idea that the project has to match with the situation of the town, the situation of the type of the landscape of the time. So when you say that working on that it becomes an object, I hope not. Maybe it's that, but I hope not. I try not. You know.
Can I just make an observation? I think a remark of this person was about maybe the concept of negative space.
What is a negative space?
Negative space is like when you do a drawing of figure and there is a void here, and this is the negative space. So I think this remarks more about, yes, you have, I really like when you were talking about the space and you would construct around the void and give a lot of importance to the void. I think the observation was when the product is there, is finished, what feels stronger is the structure, what is there, rather than the negative space. And
I don't know. I don't know. I don't know.
this is just maybe just a, and I am a structural engineer myself, so I am when I. But I can.
Don't be ashamed.
I can understand that when I design a structure, I just feel it so much. I feel so much the presence of the structure and the forces are in the structure. Then maybe I just the balance goes a bit more to the present, what is present around it, rather than a negative space.
But I really tried not to work really on those members, the forces. If you try to understand that you're not working with only, the gravity is not the fact that the force is coming from there, going there, but sometimes it can disappear, it can be more resistant, less resistant, you know. You can, imagine that you have a stone on a needle. You can, imagine things that are not only continuous in that way of what appears natural. And in the fact that I'm working more with the void, I'm trying to. Maybe it's not.
That's a very interesting research.
Because it's what's qualified the idea of inertia. It's not the material, it's just the void. And if you can make with that void, you can give scales to that. So it becomes more relative to the space and to the people than to be an object. I'm trying.
I think we're very grateful that you're trying. Thank you very much, Marc. Thanks.
Thank you.